Hello, so I'm Daniel. I'm a technical support engineer at PingCAP, and I will walk you through this presentation. So we have a safe harbor statement. You're free to read this on your own if you want, but basically it means that these things are just for your information and not part of a contract, etc. So the first thing to learn about PingCAP is about the company itself. This is the company behind the TiDB, where TiDB is the product that we have. So we have people all over the world, both in Silicon Valley, Amsterdam, Singapore, and also in China. We have multiple offices, and we did a few very successful rounds of funding, and we were funded by quite a few well-known venture capitalists. So that's proves a good base for a firm company that can take this product further. The very first version of TiDB was released in 2015, so that's quite a few years ago. So it's starting to become more and more of a mature product. And so this is trusted by many of the global leaders in both fintech, but also in a few other branches. So here you can see a few of the bigger banks. Some of them are in China or Asia, but there are also big US companies like Square. Some of the other things are in transport and manufacturing, etc. And these are all using TiDB in production. So TiDB, the product that we are offering, is based on open source. There are multiple components of this solution, and some of these components were offered to CNCF, which is the Cloud Native Compute Foundation. These components include TiKV, which does the storage part of our solution, and Chaos Mesh that's being used in our testing setup. And these have been very successful within CNCF, and our whole product is also quite successful on GitHub, attracting a lot of contributors and large-scale adapters, and it's being started on GitHub by a lot of people. So it's not just a product; it's really open source with many people being involved. It's also based on a lot of research, and we are participating in improving the whole field of database research. There were publications in top-tier academic journals, including VLDB. The TiDB Raft-based HTAP database is one of the most influential papers in the HTAP area. HTAP means combining both operational OLTP workloads with analytical OLAP workloads to the same product. We'll touch base on that in more detail later, but we are part of a lot of research there. We did this in cooperation with some of the most prestigious universities, like the University of Washington, Medicine, ETH Zurich, ARMIT, CMU, and quite a few others. We also often part of database conferences like Percona Live, which you can see on one of the pictures on the right here. So back to fintech. So fintech, what are the specific needs that many of the customers have that we see? One of them is fast-growing data and workloads. Things increase and can increase rapidly, and there are many sudden changes in the industry. At the same time, it's still financial data, and both companies, customers, everyone expects us to be very cautious with the data, that it's both correct and kept private where that's required, and that is also available when it's needed. So we need to move fast, but we also need to be very careful and have all of the required safeguards. And there's also the part where we need to have a value-added service to users based on real-time data of user behavior. The more insight you have into the data you're already collecting, the better you can make your business decisions based on this. And also users themselves are expecting more information in like the dashboards they might have, etc. And fintech needs to be more agile than traditional financial services, and needs to have a shorter time to market. There are more and more fintech companies, which means that there's a lot of competition. And that means that if you're earlier to market, then that's really a big advantage. You need to keep the pace going, because otherwise customers will just switch to another service. So the challenges with it this in this industry when it comes to databases specifically is that once the data volume or workload exceeds single node capacity, the data infrastructure becomes very complex, becomes very difficult to scale. You might want to like double or triple the amount of data that you can store. But to do this, you don't need to just add more resources, but you also need to change the whole infrastructure and redesign components, which becomes quite intensive, both in money-wise and in the time you need to put in. Real-time insights become much more difficult on a larger scale, which means that if you want to have the same information, then you need to add more and more resources, and it's getting more and more difficult to make it as real-time as possible. And because you're spending a lot of time on actually scaling things up and keeping things working, you're becoming slower with your new iterations of your product, which can give other companies an advantage. You also need to work with regulatory compliance, especially with financial data, with PCI, GDPR, and all the other things. This need makes things even more complex than they already were, especially at a larger scale. And then we go to how TiDB helps with this whole situation. So we want to have the business value of being agile, which means faster time to market and continuous iterations. How TiDB helps here is that it simplifies the data infrastructure. And instead of like spending a lot of time in changing the architecture and improving the architecture of your data infrastructure, you can just spend time on improving the product instead. Scalable. So we want things to be scalable to empower business growth with less efforts and better reliability. Well, one of the big advantages of TiDB is that it's a scalable database. We did this by completely re-implementing the database from scratch and keeping scale in mind in all the parts that we did. And the results is that you basically just add more resources and it scales. It also doesn't need as much resources as some other products do, because we are more efficient in how we are storing data, for example, than some of the competitors. So with a moderate amount of resources, you can already scale quite a lot more. real-time. We want real-time instant business decisions and value-added services like extra dashboards to the user based on real-time data. Not yesterday's data, not this morning's data, but real-time data. The data needs to be consistent and also not like pre-computed because we want to give the options to have ad hoc queries, etc. So we do this by having a component type flash that enables us to have HTAP. HTAP means that we are combining analytical properties of a database with the regular row store properties of a database. The combination of this leads in a product where we can just store data as usual, but also have very fast analytical queries that, for example, do a sum or an average of a column. So basically, what we are is an elastic MySQL database for massive business growth. As I already explained, we have the horizontal scalability where you just add more resources. We have high availability. This means that if any of the components fail, we have a fail-safe. It just fails over to a different component and it just continues working. You just replace the failed components, but there's no downtime. And also the failover is transparent to applications. And the failover also does not need any manual steps. We are compatible with MySQL. So if you're already using MySQL in your operation, you can mostly just switch out your existing database for TiDB and expect most of the things to just work. This also means that you don't have to change a lot on your application. You don't have to retrain all your developers, etc. You can just reuse a lot of the things you already have. And instead spend time on improving the product instead of just working on migrations. We are strongly consistent, full asset transactions at scale. This might not look very spectacular, but while smaller databases like MySQL often do also have asset consistency, larger databases and MySQL, when you're using sharding, stop having the same properties, and we can still guarantee that transactions are consistent and durable, etc. This just reduces all the fault scenarios that you might have. So in the end, we are empowering real-time insights. We're improving business agility with a simplified architecture and lower maintenance cost. So here we will get to a bit of a more technical explanation about how we were able to do this. So this is a cloud-native distributed HTAP database. We have a cloud service, but you can also run this as an on-premise service. It starts with a stateless SQL layer that's compatible with MySQL. That's what you see as TiDB in the schematic on the right, which means that any of these can just fail and they will just restart. And it's completely high available. There's no leader, there's no follower. Any of them can get read transactions. Any of them can get write transactions. They're not storing data themselves because the data is being stored by the key value store. That's the TiKV that you can see on the right. You don't need to specify which TiKV you want to access or anything. TiDB knows how to distribute the data over multiple TiKV servers and make sure that if one of the servers dies, that there's always a copy available on one of the other servers. So there's nothing you need to do yourself. It works all automatically. The other thing that's there is the TiFlash, the analytical storage, which just stores a copy of the tables where you need this. And it's storing this copy in a columnar format, which has the same properties as a columnar database. But because we also have the transactional database, TiKV, it's possible for TiDB to combine data of both storage options. By combining this, it's more efficient. We don't need to have a full copy in the analytical database. And it's also way more real time because it just all consistent with each other. It's not like that we're shipping data or anything. The PD that you can see on the bottom, that's just basically the brains of the whole cluster. It's also high available, but that's where it makes all the decisions about where to place what data and how to handle like replacement of machines, etc. We have this as a fully managed service on AWS and GCP. If you have another cloud provider, it's possible to deploy with Kubernetes. So of course, in the financial services, it's important to have compliance. So we are SOC 2 compliant. We are ISO 27001 compliant. This is the security part. Then we have ISO 27701, which is the privacy part. We have GDPR, which is the privacy protection of the EU. There are more on the way. This will include PCI DSS for TiDB Cloud, but it's already possible to run TiDB in PCI environments. So now we talked about what the problems are that are in many financial service companies have and how TiDB can help. Here we will go into a few customer cases to just demonstrate a few specific cases where TiDB helped the customer to improve their operations. So the first one is a Web3 customer case. The customer is a major player in the Web3 industry. This is the whole industry with the blockchain, etc. It uses TiDB to integrate data silos from numerous AWS Aurora and forms a global view about multiple aspects of the business operations. So here all the operational data is first stored in Aurora, then it's transported to TiDB, and on TiDB it's actually doing the analytics, and it's able to have a lot more data than that's in a single Aurora. So it's able to handle the large volume, but it's also able to do analytics on this, and also to do this in an efficient way, which lowers the cost of the whole solution. Another Web3 customer case. And by the way, while this is also Web3, it's will also apply to many other similar cases that are not directly linked to Web3 and blockchain, etc. Here it's using TiDB to store real-time data from a public blockchain and provides insight to users. So it's a large amount of public data that's harvested and stored in TiDB. And then with querying TiDB, the analytics part will give all kinds of information to the end users of this product. This is a very large amount of data. It's around 60 terabytes, and this is hot and real-time data. So it's not an archive, it's real active data. And it's serving 30,000 writes a second and 6,000 queries from end users. And this supports full SQL with hybrid workload, with a very low overhead for maintenance. And this is another customer of ours. It's PayPay. They're located in Japan. It's the largest mobile payment company in Japan. And TiDB supports its core payment service. So the business imperatives they had were like the growth of e-commerce, smartphones with e-money, which is their payment option. They had that 1 out of 4 tourists were 1 out of 4 customers of them were tourists. That was before COVID-19, but during COVID-19, a lot of contactless payments started, and they became much more successful. So before TiDB, the payment and wallet backend was a database on AWS Aurora. And they had a single master Aurora cluster, which is how Aurora works. Because an Aurora cluster will have only a single master, but there are multiple servers that can take over in case the single master fails. But the single node wasn't able to handle the write load and wasn't able to scale further. And that was a serious limitation for them. There was a transaction history table with 20 billion rows and 50 columns, and the number of queries per second and the latency of the queries was not satisfying to them. They had a lot of scalability challenges during the campaigns they did, because of course with COVID-19 they saw the opportunity of getting more customers because of the changed requirements of customers and changed expectations, because contactless was suddenly way more popular. So with TiDB, they were able to get 2 to 3 times customer growth, 3 to 4 times merchant growth, and a TPS increase from like 400 to 2,000, and QPS from 1,000 to 20,000. So everything they had on their business metrics like scaled massively, and the product was able to also scale at the same rate. So in the end, this was a big success, both for the product and for the company. So why did they choose TiDB? Well, the quote there says that TiDB reduced the latency for commit, handled 3 times more transactions, and migrated within 3 months. So that's the time to market that we already mentioned. That is a very important thing to keep in mind. So one of the things that allows them to do this is the compatibility with MySQL. They don't need special TiDB drivers or programming libraries, etc. They can just use MySQL, which is the same protocol that Aurora is already using. So they didn't need to rewrite all the database things. Many, maybe even all of the things that they do could just be migrated as is. No sharding required, because if you do sharding, a lot of things suddenly become a lot more difficult, because if you have multiple shards and you, for example, want to do analytics and you want to get an average, you can just get an average from like 3 shards and easily combine them. Now you need to get like the raw data from shards and combine them for each analytical function that you want to do. And this just gets a lot more complicated. And if you have shards, then you might want to add or remove shards, because maybe you're scaling either up or down. And many sharding solutions are not really built for this. And then scaling up and down can really be very time and labor intensive. But with TiDB, that's all behind the scenes. No interaction is needed. And it just basically works, especially for the developers. That's a big win because they just don't need to care about this. Seamless horizontal scaling for read and write. Well, many products allow you to scale reads, to just have a higher read load. Scaling writes is where many of the products start to fail because they are just not able to scale the writes over multiple nodes. With our solution, writes are going to multiple nodes. So if you don't have enough write capacity, you just add more nodes and the amount of write capacity you have will just automatically increase. We also were able to supply them with proven references, reference cases in the Fintech industry, because we were already working with a few banks. Square Cash App. So the Cash App is one of the services that Square has. They were using a product from a competitor. The product is called Vitesse. And they were using Vitesse with AWS Aurora because Vitesse only implements part of the solution and leaves the other parts to Aurora. And TiDB implements the complete solution with TiDB as SQL part and TiKV and Flash as the storage part. And because we are doing this, the storage part is more optimized for the hardware that you're likely to see today. And because of that, the storage is just a lot more efficient and lower cost. So in the end, they were able to get lower latency and to scale transparently without any manual sharding, without specifying sharding keys, with strong consistency on the whole setup, etc. So that worked out quite well. Again, MySQL compatibility. So Vitesse is using the MySQL protocol. We are using the MySQL protocol. And we have the same syntax, mostly as the MySQL 5.7 server has, with a few added things from MySQL 8. We were able to provide asset transactions while being elastic and scalable. We were able to provide them with global indexes. That's something that Vitesse doesn't provide. And our scaling is very easy with no downtime for scaling in, scaling out. It just all works automatically, basically. And they really like our technical support. And this is the last customer case. It's WeBank. So you might know Tencent, which is well known for having WeChat. So WeBank provides financial services to small and micro enterprises and individuals. By the end of 2020, they served 270 million individual customers. That's just such a massive amount of customers. And they have 1.88 micro and small enterprise customers. This is also a huge number. And it had a peak of 750 million financial transactions in a single day. Those are just financial transactions. So the database itself will be doing a lot more transactions because not all of the things going to the database are financial transactions. the scenarios and challenges were a large scale of batch application, including online loan accounting, core batch accounting, and unified reconciliation, with batch writes and updates of over 100 million rows. The workload for the MySQL-based single instance database was very high, with like 70% of I/O and CPU in use, and it was already a very big instance. So it's again the limitation of having a single instance as the writer. They might have high availability, they might have read scale out, but the write part was just not scalable beyond a single instance. They did have a few huge tables, and it took them a long time to update columns with the DDL. So just adding, removing columns, etc., took a long time with the pre-existing solution. And they wanted to do online transaction. They want to have an online transactional database with batch workloads, and for them the batches were affecting many of the online transactions and causing impacts to the online transactions. So the TiDB solution is this. They deployed across 3 availability zones in the same city for high availability. The data is streamed from the data center node to TiDB in real time. Then on TiDB, batch processing is done, and the results are written to the big data platform. That's, I think, based on Hadoop, and then from there it's used further in their stack. The batch processing capability can now be scaled with TiDB horizontal scalability. And as you can see, this looks a bit like one of the first customer cases that we handled, where they had AWS Aurora data going into TiDB, and then in TiDB things were combined. So this is a very common first step to do when people are moving to TiDB, to have the operational data written into TiDB. There they can do analytics, see how the product works, get familiar with the product, and then one by one they can just switch and start to write directly into TiDB also for their operational queries and workloads. So why they chose TiDB is again because of it's MySQL compatible. The product they were using before was also a MySQL compatible product. It's horizontally scalable, ROF-based multi-replica of data guarantees availability and strong consistency. The strong consistency is not just within a single row, it's in the whole system, even if it's data on multiple nodes. And we have a very active open source community, and it's a very healthy state for a product to be in. It's already battle tested by a lot of internet giants and a lot of other financial companies. And here there are some statistics about how they were able to actually improve the business metrics with TiDB. So many of the loan services just at the time taken into like less than half. Thank you for attending this webinar. I hope you learned something out of this. And there's a QR code. This helps you to see what our TiDB Cloud product is.
Thank you, Daniel, for this. Also, just to mention that you can use with this code free developer tier for 1 year, which means you can upload data up to 5 megabytes.
I think you can upload like 500 megabytes or even more. with a developer account, as you said.
Okay, sorry, then as Daniel said, up to 500 megabytes. Just use the QR code, scan it, and then it will bring you to the website, which you'll find all the information about. So thank you, Daniel, for this valuable information, and I hope you all enjoyed it. Thank you.